Alright guys, as per usual, here is your review solved with all work shown before the test. That is on Thursday, so let's go. We'll start with just number one. All of these are complex number operation problems. It says, in the complex number system, simplify 4 minus 6i, which is a complex number, minus 8 minus 9i, which is a complex number. You're just going to solve these as though I was just a regular variable. So let's just rewrite the equation real quick. 4 minus 6i. If you are not distributing anything, you can drop these parentheses. But as we look at the second part of this expression, we actually do need to distribute this negative sign, hippity-hoppity distributive property, into the parentheses before we write it down. So that positive 8 will become a negative 8, and that negative 9i will become a positive 9i. Then I just combine like terms. I have 4 minus 8, that's negative 4. I have negative 6i plus 9i, that leaves me with 3i. And that is the answer. Okay, 2. In the complex number system, simplify 4 minus 3i squared. That is a complex number. That is 4 minus 3i times itself. That's what squared means. So we'll rewrite this as 4 minus 3i times itself. 4 minus 3i. And now you can use the box method or the distribution method. I prefer the distribution method, but I will demonstrate the box method. We are going to write 4 minus 3i, 4 minus 3i, and then we will make our little grid here. I should have put that negative sign closer to the 3i, but I think you get the picture. 4 times 4 is 16. 4 times negative 3i is negative 12i. Negative 3i times 4 is also negative 12i. And then negative 3i times negative 3i is positive 9i squared. We combine our like terms, and we get this expression. We have 16 minus 24i plus 9i squared. And as I told my students, I should never have an exponent. If it has an exponent, you're doing it wrong. You got to simplify it. You got to remember that I is equal to the square root of negative 1. So I squared is equal to the square root of negative 1 squared. The square root sign and the square will cancel out, so this will become 16 minus 24i plus 9 times negative 1. In other words, negative 9. So we have 16 and we have negative 9. 16 minus 9 is 7. And 7 minus 24i does not simplify. That is simply a complex number, and it also happens to be the answer to this question. Alright, I'm going to clear this up before I do the last one. Actually, no, I don't need the room. It's just an easy addition problem. We'll just drop the parentheses because there's nothing to distribute. It says simplify 3 plus 8i, so we'll write 3 plus 8i plus 6 minus 5i, so plus 6 minus 5i. We just combine our like terms. 3 plus 6 equals 9. 8i minus 5i equals 3i, positive 3i. So this is the solution. That was the solution to the first 3 questions. Let's move on. 3 points on a quadratic function, 0, 5, 2, negative 5, and 4, 1 were used to set up a system of 3 equations and 3 variables to determine the coefficients and constant term of the function in general quadratic function form. F of x equals ax squared plus bx plus c. The system based on the 3 points is shown below. Solve the system to determine the values of a, b, and c. Now, what I would suggest you do is just write this in a form that you can plug into a matrix and then solve it. I will, however, solve it by hand, but if you wanted to solve this in matrix form, we would have to sort of simplify this a bit. Let's start with this first equation here. A times 0 squared. 0 squared is 0, and 0 times a is 0. Just for the sake of creating a matrix, I'm just going to write this as 0a. B times 0 is also 0, but I'll go ahead and write 0b. And then we have 1c, so plus 1c equals 5. If I were to put this in the top row of my matrix, it would be 0, 0, 1. And then we'll get to the second matrix in a second. Okay. The a term, we have 2 squared, that's 4, so this would be 4 times a. I'm working on the second equation now, I don't know if that was obvious. B times 2, so we would have 2b, and 1c equals negative 5. So the second row of my matrix would be 4, 2, 1. All right, time for the third one. We have 1 squared, that's 1. 1 times a is 1a. 1 times b is 1b, and c is 1c, so just a bunch of 1's equals 4. So the last row of the matrix would be 1, 1, 1. Here would be my first matrix. Don't forget to invert it when you're typing it in. The second matrix consists of the constant terms of those equations, so 5, -5, and 4. And when you plug that in, you will get the answer in terms of A, B, and C. Okay, so that's how you'd put it in on a matrix, but I'm going to do it by hand. It's going to take a little bit longer, but it's good for our edification. Right off the bat, I can see that these 0 terms are going to cancel each other out. I mean, not cancel out, they just simply won't be there. 0 times A is 0, 0 times B is 0, so I have 1C equals 5. So I actually already know what C is. C is equal to 5. I can just keep that as it is. Then I've got 4A plus 2B plus 1C equals -5. Well, if C is 5, I can actually plug that in. 4A plus 2B, substitute the C for 5, so plus 5 equals -5. This equation can actually simplify a little bit more. I'll write it in a different color. It's going to be 4A plus 2B. And if I subtract 5 from both sides to get the constant on the same side of this, it'll be -5 minus 5, so that's going to be -10. All right, that's about as simple as I can make this equation. Let's go back to red and tackle the third one. So we've got 1A plus 1B plus 1C, which we know is 5, so we can write this as A plus B plus 5 equals 4. And just like the previous equation, we can get the constants on the same side. We'll have A plus B equals 4 minus 5. That's going to be -1. So now I have a system of 2 variables and 2 equations, so I can use either substitution or elimination. I think I'm just going to go for elimination in this case. Nice and simple. We're going to multiply everything on this equation by -2. That way I can cancel out my B values. You'll see that in a second. So I'm just going to write that first top blue equation there, 4A plus 2B equals -10. Okay, now I'm going to put our new and improved bottom blue equation after I multiply -2 by everything. So we'll have -2A minus 2B equals 2. Okay, we'll add these equations together. We will combine them. 4A and -2A will become 2A. The B terms will eliminate. That's why it's called elimination. And they will equal -8, which gives us a simple problem. Divide both sides by 2. A we find is equal to -4. So now we've got 2 variables. We've got C equals 5. We've got A equals -4. Time to find B. All we have to do is substitute back into one of those original equations. I'm going to choose the bottom one because it looks nice and easy. 1A is going to be -4, plus 1B, that's just B, plus 1C, that's 5, equals 4. Combine my like terms. I've got B plus 1 equals 4. Therefore, B is equal to 3 after we subtract 1 from both sides. So here's my solution. The ordered triple will be A value, -4, B value, 3, C value, 5. That's the way it is. All right. Now here's an interesting graphing problem, and I'm sure most of you will just be able to type this in on Desmos and say, oh, that's what that looks like. You know, of course you're going to have multiple choice answers, but in real life we don't have multiple choice. We've got to start from scratch. So what I want to do is I want to use my knowledge of quadratics to figure out what the equation of this is. Let's identify the vertex. That's a good point to start with. It is at -2 in the x direction, -2 in the x direction, +2 in the y direction. Okay, so there's my vertex. I can see that my y-intercept is here at +10. That's a 0 in the x direction and a 10 in the y direction. All right, using this information, I think that's enough for us to find out the entire equation. Because the vertex form is the easiest to plug into, I think that's what I'm going to start with. For those of you who don't recall, y equals a x minus h squared plus k is my vertex form, where hk is my vertex. So if I plug this in, I'll grab a different color. It's going to be y equals a. We don't know that yet. I'll show you how to find that in a second. X minus h. So -2 minus -2. And since I'm subtracting a negative, I can create a positive with that. Plus k. That's +2. All right, now I just need my a value. What's my a value going to be? Well, there's only really one way to find that out, and that's by plugging in this other point that we happen to have gathered. The y-intercept is probably one of the easiest because it makes x 0. It's always easy to work with 0, at least until you get to calculus. So y equals, oh, sorry, I'm not quite right there. Y, in this case, is going to be equal to 10 because that's the y value of our point, 0, 10, equals a times x, we said is 0 because the point is 0 in the x direction, 10 in the y direction, plus 2 squared plus 2. Now we only have one variable and one unknown. We can solve for it. 10 is equal to a 2, because 0 plus 2 is 2, squared plus 2. PEMDAS, please, exponents before multiplication. This 2 is going to get squared first. I will have 10 equals a plus 2. I'm going to move up over here just to finish this off. I can subtract 2 from both sides and wind up with 8 equals 4a. Divide both sides by 4, and we find that a is equal to 2. 2 equals a. So if I wanted to write my equation, this is going to be the equation. Y equals a, which we just found is equal to 2, x plus 2 squared plus 2. I just plugged my a in right here. Everything else is the same, okay? This is in vertex form, but just in case they want it in standard form, we can go ahead and just multiply everything out. Y equals 2. We got to do our exponent first. PEMDAS, people, PEMDAS. I'm going to use the distribution method. You can use the box method. It's whatever you prefer. X times x is x squared. X times 2 is 2x. 2 times x is 2x. So we're going to have a total of 4x in the middle there. And then we have 2 times 2 is 4. So here's my trinomial. It happens to be a perfect square trinomial. We're going to add 2 on the end. Can't forget about Kyle there. Distribute and combine like terms. So I have 2x squared. 2 times 4x is 8x. And my constant term will be 2 times 4, and that would be 8, but I'm also going to have that plus 2, so 8 plus 2 equals 10. So this is my standard form equation. There's other ways to figure it out. You could have found out what the axis of symmetry is right there in the center. I leave that to your imagination. I showed you how to do it one way, but there's about 30 other ways to do it. Pick the way that works best for you. Let's move on. All right, complete the square of x squared plus 12x plus 25 equals 0 and write the equivalent equation of the factored perfect square trinomial. So it doesn't actually tell us to solve it. It just says to write the equivalent equation of the factored perfect square trinomial. What does that mean? Well, I'll show you what it means. It means that if you've got x squared plus 12x plus 25, and you want to complete the square, the first thing you need to do is get the x values on one side and get the constant values on another side. So that's going to turn into x squared plus 12x. We're going to subtract 25 from both sides, so we'll have negative 25 over here. Now, in order to actually complete the square, we need to add the value of b over 2 squared to both sides of this equation. Okay, I'm going to do that in green. X squared plus 12x. Okay, what exactly is b over 2 squared in this case? Well, b is a value of 12, so we're going to have 12 over 2 squared. In other words, that would be 6 squared, or 36. So I'm going to add 36 to both sides of this equation. 36 equals, what is negative 25 plus 36? That's going to be 11. All right, so now this is a perfect square trinomial. I can put it in binomial squared form by factoring. It's going to be x plus 6. X plus 6, because it's going to be either half of this b term or the square root. Actually, it's not going to be either. It's going to be both half of this b term and the square root of this c term. Equals 11. So now that's all they were asking for. There are some other examples of how to completely solve it. I'm sure we're going to see a few in a second, but really this is all they wanted. So that's where I'm going to leave this particular problem. Let's see number 7. A quadratic equation is shown below. 7x squared equals 11x minus 2. What are the solutions to the quadratic equation as an exact expression? Exact expression means decimals. Everything's going to be as a fraction or a radical. So let's go ahead and get started on this one. Let's see, what do I want to do first? I could plug this into the quadratic equation. I think that I'm just going to go ahead and complete the square and see how it goes. I'm going to move that 7x squared to the, you know what, no, I'm going to do the quadratic equation because you've seen complete the square. Let's do the quadratic equation. That's going to be x equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. And this follows the form of 0 equals ax squared plus bx plus c. So let's put it in standard form first. Let's get the 0 by itself by subtracting 7x squared from both sides. Let me change my color. 0 equals negative 7x squared plus 11x minus 2. Okay, let's start plugging this into our equation. We have x equals negative b, so that's going to be negative 11 plus or minus the square root of b squared, so that's going to be 11 squared minus 4 times a is negative 7 in this case, times c is negative 2 in this case. Extend my radical a little bit. All of that over 2 times a, and as I said before, a is negative 7 in this case. Okay, now we just have to get to the matter of simplifying all this nonsense. Negative 11 plus or minus the square root of, let's see, 11 squared is 121 minus 4 times negative 7. 4 times negative 7 is negative 28. And negative 28 times negative 2 will be positive 56. So I'm subtracting positive 56. All of that over 2 times negative 7, that would be negative 14. Okay, it looks like we are almost done here. Negative 11 plus or minus the square root of what is 121 minus 56. Excuse me, it's going to be, let's see, 4 plus 21, 65 if I'm not mistaken. 44 plus 61, yeah, 65. So I actually made that radical much bigger than I needed to. I'm going to erase a little bit of that. Okay, over negative 14. And if this were possible to simplify, we definitely want to do that. Get out any common factors or anything like that. Make sure that there's no imaginary numbers. But in this case, it actually is simplified, and I can show you why. That square root of 65, if I were to try and break that up into a factor tree, it would be 5 times 13. And both of those are prime numbers, so there really is no way of simplifying this radical. This happens to be what the problem is asking for. It wanted it as an exact expression. Well, there it is. You could put two different expressions. You could have negative 11 plus square root of 65 over negative 14 and negative 11 minus the square root of 65 over negative 14, but this is okay with me. Okay, let's continue. Number 8, what are the complex solutions to the following equation? Complex solutions. I think this time, instead of doing the quadratic formula, I will complete the square. I think it's a little bit easier. You guys need to see both, as many examples of both as possible. So let's see. We're going to have 2x squared. The first thing I want to do is get the constant away from my x's. So 2x squared plus 4x. So I'm not going to put the plus 6 here. I'm going to subtract 6 from both sides. And, oh, actually, I'm violating my steps. The first thing that I need to do, let me write this all out as it is. The first thing I need to do is get rid of my a value. That a value needs to be a 1. Otherwise, this is going to be a lot more difficult. So I'm going to make this a value equal to 1 by dividing every single term in this equation by 2. That's going to become x squared. This is going to become 2x. This is going to become 3. And 0 divided by 2 is just 0. So we'll keep that the way it is. Now I'm going to move my constant to the other side. We'll have x squared plus 2x equals negative 3. Now I'm going to do what's called completing the square. I'm going to change my color up a little bit. I need to add a term to both sides of this equation that will make the left side a perfect square trinomial. The way that I do that is taking half of the b term and squaring it. That's the number I'm going to add. So half of b in this case is 1, and 1 squared is 1. So I'm just going to add 1 to both sides. Okay, so this is a perfect square trinomial. I can actually tell you what that square is. It's going to be x plus 1 squared. Okay, it's going to be x because that's the square root of x squared. It's going to be 1 because that is both half of 2 and the square root of 1. And that's equal to negative 3 plus 1, which we all know is negative 2. Okay, now I can go ahead and finish solving it. I'm done completing the square. I'm going to switch color because this is the next phase of our problem solving. I'm going to take the square root of both sides. The square root of a square is just whatever is in the radicand. So that's going to be x plus 1. That square cancels out. But over on the right side, we're going to have the positive and negative square root of negative 2. That square root of negative 2, when we have the square root of a negative, we know that we're working with imaginary numbers. So let's just go ahead and rewrite that right now as x plus 1 equals the positive or negative square root of 2, positive 2, times I, where I is our imaginary unit, the square root of negative 1. Okay, let me go up to the top and finish this guy out because this is the very last step. It's not going to simplify anymore. I'm going to have x equals negative 1 because I'm going to subtract that 1 on both sides. Negative 1 plus or minus the square root of 2 times I. I could write that as two expressions, one with a positive sign and one with a negative sign, but this is good enough for me. I think we're done if I could actually box that right. Close enough. Okay, what number was that? That was the top one. Oh, okay, we still got quite a bit of work to do. Let's do it. Let's erase all this gobbledygook and start on number 9. Number 9 says, what are the solutions to the equation 6x minus 18 squared equals negative 120? Let's go for it again. It looks like we don't have to do any completing the square. We don't need the quadratic equation, the quadratic function, formula, that's what I meant. We're just going to go ahead and jump right in with a regular algebra problem. We need to get rid of the squared, so the first step that we're going to have to do is take the square root of both sides. When we take the square root of the left side, because it's already a perfect square, we're just going to say that it's 2x minus 18. That cancels out the square. On the right side, however, we're going to have the positive and negative square root of negative 120. There we go with negative square roots again. That's going to be an imaginary number. So let's find out what kind of imaginary number that is. That's going to be 6x minus 18. That has not changed, but we're going to have plus or minus. Let's go ahead and get this this 120 factor down and simplified. We're going to have, we can say 60 times 2. This could be 30 times 2. This could be 6 times 5. This could be 3 times 2. So it looks like we have one pair and a bunch of not pairs. we have this one pair of 2's that we can take out, and the rest of this stuff is stuck inside by its lonesome. It's going to get meshed back together. Okay, so we've got 2 square roots of 3 times 2 times 5. 3 times 2 is 6. 6 times 5 is 30. So we're going to have 2 square roots of 30, but we can't forget that used to be a negative number. Let's just put our I here before we forget. Okay, we're going to add 18 to both sides. 6x equals positive 18 plus or minus 2 square roots of 30i. And now we're going to divide both sides by 6, and we should be pretty close to our answer. 18 plus or minus 2 square roots of 30i all over 6. And now this seems like it would be the end of the line, but it's not, because all of these guys have a greatest common factor of 2, so this is actually a fraction that can be reduced. If we divide 18 by 2, we'll get 9. Plus or minus, if we divide 2 by 2, we'll just have 1 left, so it's just going to be the square root of 30i. And then on the bottom, 6 divided by 2 is 3. So this is actually the solution, or I should say solutions, because there are 2 of them. We could write it in 2 separate expressions if we wanted to, one with a positive sign, one with a negative sign. But that's it. That's really all there is to that one. So let's move on to number 10. What are the solutions to, and it looks like this one's another easy completing the square problem, so let's do it. Let's divide every term in this equation by 2, just to start out with. So we'll have x squared minus 6x equals negative 10. They're loving these negative numbers. We have a lot of imaginaries here. Let's complete the square. We've got x squared minus 6x. We're going to add half of this squared to both sides. So half of negative 6 is negative 3, but negative 3 squared is 9. So we'll add 9 to this side. And if we add 9 to the left, we have to add 9 to the right. Otherwise, it won't be bound anymore. So this is a perfect square trinomial. That's going to be x minus 3 squared. On the right side, negative 10 plus 9 is negative 1. So let's take the square root of both sides. We'll have x minus 3 equals the positive and negative square root of negative 1. And that is a very familiar number to me. The square root of negative 1 is actually I. So we can simplify this down a little bit by writing this as I, plus or minus I. Okay, now all that's left is I have to add 3 to both sides. X will be by itself, and I'll have my solutions. 3 plus or minus I. So that's 3 plus I and 3 minus I. Those are both of our complex solution. That was a nice quick one. Let's keep going. Last one. I think I'll do I think that I'll go ahead and do a quadratic formula just to show you that one again. So let me write our quadratic formula here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so let's see. Change my color. So x equals negative b, negative 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, where a is positive 2, times c, which is negative 40, all over 2 times a, which is 2. Time to start simplifying. Negative 2 will just be positive 2, so positive 2 plus or minus the square root of, let's see what we got here. Negative 2 squared is 4, minus 4 times 2 is 8. 8 times negative 40 is positive 320, so, minus 8 times negative. So this is going to be plus 320. Which I believe we're on board to a perfect square. Let's just see how it goes. 2 times 2 is 4. So 2 plus or minus the square root of 324, which I believe is a perfect square. I don't quite remember what it is. We'll go ahead and see by doing a little factor tree. 324, that's going to be 162 times 2. That's going to be 81 times 2. Okay, that's easy. So 9 and 9. So this is going to be, we're going to put a 9 on the outside. We're going to put 2's on the outside. So 9 times 2 will be 18. Apparently, the square root of 324 is 18. You'll have a calculator. Don't worry if you didn't follow that. 2 plus or minus 18 over 4. X equals, we can actually reduce all this because they have a greatest common factor of 2. So 1 plus or minus 18. Nope, sorry, not 18. Divide by 2. 9 over 2. So we can actually get some real numbers here for our solution. 1 plus 9 over 2. 1 plus 9 is 10. 10 divided by 2 is 5. So we have x equals 5. And then 1 minus 9 is negative 8. Negative 8 divided by 2 is negative 4. So the two solutions to this are going to be 5 and negative 4. And that, I believe, is the end of the exam. That last problem you could have solved by completing the square. That would give you fractions. I don't think they're very hard to work with, but you just do whatever you feel comfortable with, and hopefully you'll all get excellent grades on the test. That's it for this video. Bye!